Yeah, a bit of a word salad, simplifying development for complex applications. Just an introduction about myself. So I've been using LabVIEW professionally for about 25 years. Started working in defence in Melbourne, same company as Chris. Moved to Sydney around 2003, was working for a alliance partner here in Sydney. Nancy, I was in that course, remember, 2004. She taught me everything I know about LabVIEW. So if anything's wrong, just ask her. So yeah, worked alliance partner here in Sydney for half a dozen years or so. When worked for a research company. About 10 years ago, set up Software Systems. I've been managing a team of developers for the last decade. And this presentation is really about, having been around for a while, is you tend to find that you're still supporting a lot of legacy projects. It's really about how to make sure that when you're developing your applications, you're thinking about how you're going to be able to support them, or what is usually the case, how someone else is going to support them because you've moved on to something a bit brighter and a bit shinier. Okay, so for our giants of female, I grew up in a small town in country South Australia, and in the early 80s, we got our first computer. Very exciting. It was the first one in town. And the reason we had one was because my mum, she was doing a computer science degree remotely, so not over the internet, obviously, sending out big packages and getting them back. And she was doing that whilst she had 4 children. I was the oldest, so the youngest one was still in nappies at that time. So that's where I learnt my computing skills, as they were in those early days. And she obviously was doing her course and started doing training and started doing some community programs and all that. I remember when my school got its first ever computer, they took myself and my sister out of class, wheeled us in front of the teachers and said, "How do you turn this thing on? What's the mouse?" And all this other stuff. So that was pretty cool. Got a day off school for that. So my mum kept up with it. She was teaching a lot of courses. She ended up being a lecturer in computer science. She was involved a lot with government in South Australia, doing educational programming, bringing computing skills to disadvantaged communities and Indigenous communities. So my pick for the giants of female is my mum, Margaret Granger. She unfortunately passed away a few years ago, but she left a really good legacy within our family and within the community on the whole. Right, so getting back to the main topic, just a bit about the audience. How many people here would consider themselves to be certified LabVIEW architects or around that level? Yeah, probably about half. So this presentation might be preaching a little to the converted. It's really, talking about the way in which the teams I've worked with do things. It could be similar to the way you do it. Some things might be different, might generate some discussion. Hopefully no one gets too upset. For the rest of you, how many of you would be considered certified LabVIEW developers or something equivalent? Yeah, it's probably most of the rest of you. See some of my team members put their hands up, that's good. Hopefully this gets you to think a bit about your next project, thinking about the development methodologies that you're using and how perhaps your team can evolve and do things a little bit better. So this is really sort of tailored towards you. And I'm assuming the rest of you are either new users, uninitiated, or just perhaps a bit shy. It's also important, I suppose, if you're just starting to use LabVIEW, that you're starting to think about style and how you're going to develop your code, how you build your simple applications and how they can be extended into much more complex applications. I think it's important that if you are a new developer, you don't go in there all guns blazing and start learning about active framework and all the really complex architectures. That can take time. Hopefully you've got a team around you, someone else can worry about that. You can just concentrate on doing the little things right, and we'll go over some of those things in this presentation. Okay, so what do I mean when I say a complex project? For us, it's usually something like a production station where you might have part loading and camera or motion, something that's going to have to be pretty robust. It's going to have to work without too much maintenance for a period of time. It could be a test station. It could be something that's integral to testing important products. So you need to make sure that your test station is built right and is going to give quality inputs and quality outputs. And really any complex project is one with, a large application with a number of interfaces. Those interfaces could be devices, it could be different users using them, it could be an R&D project. where you're doing a prototype and someone needs to do a whole bunch of scripting, and they can get quite complex at times. And for these projects, it's usually pretty common that there are specific project needs. Just about everyone wants rapid development, and that's rapid, not rushed. There's a difference. We all know what rushed development looks like. Usually these projects have some form of formal release procedure. So especially if it's production or important test stations, you're going to need to have a change order requests. So you need to make sure all your code's managed through repositories and a formal release procedure, so everyone knows what they're working with. You can revert back if you need to, and everything's under control. And then it's really important, I think, that when you're thinking about your projects, you're thinking about the length of the project. I'm not talking about the development time. Everyone can do a project in 2 months. But if you're building a production station, that project might need to be supported for a decade. So when you think about your code, and as Nick was saying, sometimes you look at your code from 3 or 4 years ago and go, oh my God, what was I thinking? Times that by 2, imagine someone who doesn't work for your company anymore or was from a different company. You can easily see how one person's beautiful architecture is another person's nightmare. So it's important that we're thinking about our development, not your code, Nick, your code's fine, don't worry. Make sure that we're thinking about how we're going to be able to support this project through its full lifetime. This presentation is not about architecture. There are lots of architecture choices that you can make. It's really about development methodologies. We want to try and encourage code that's easy to develop and easy to support. It's code that needs to meet your business needs. So you want to do something that's going to be quick and efficient to develop. It's got to meet the customer needs. It's got to work. There's not much point having the best code in the world if it doesn't work. But you also need to, as I say, think about those future needs. How are you going to support it? How are you going to upgrade it in a couple of years' time when components need to be changed? And so obviously architecture is really important there. It's important that you choose an appropriate architecture. If you're doing a mission critical system with rockets and all that, a simple state machine probably isn't going to cut it. But I would say that the opposite is true, and sometimes people see an application which, is not that complex, and they'll go, oh, I'm using I want to use Active Framework for this, or I want to use some other cool architecture that they read about in the forums, and you end up making a very simple application of something very complex. And whilst that might be good for your personal development, it's not good for the poor sod who's got to support it in 5 years' time, who's got to learn about all these complex frameworks or these really cool stuff that you've done, which wasn't really fit for purpose. I think we've all been there. We've all had other people's code and looked at it and gone, that's actually really simple and you've made it very hard. Well, I know I certainly have. I'm sure people have looked at my code and said that over the years. So having said that, when it comes to different architectures, there are a lot to choose from. I talk about Active Framework, which is a really, in my mind, quite a complex architecture, but it has its place for particular applications. There's other frameworks like the plugin architecture, and I think Kurt's going to be talking about that tomorrow. That has a very good use case around test systems, especially in a highly regulated environment. I'm not too familiar with DQMH. I haven't used that much myself, but I like the look of it and the feel of it. It looks like it's designed to be something that's pretty easy to pick up, and there's a lot of tools around that. So that seems like a pretty good option. I'm keen to see some of the presentations on that this week. For us, for most of our applications, we just use a version of producer consumer. It's really simple. We like that because, if you have a team of developers who have different skill levels, if you're collaborating with your clients and they might only be pretty new to LabVIEW as well, it doesn't take too much once you've got past the basic LabVIEW training, be able to get someone to use the producer consumer architecture in a way in which it's designed to be used. And that gets them efficient straight away. It's not the answer to all solutions, but I find it's the answer to most situations. Obviously, it's important in your development team and in your company that you have a bunch of tools that you and your team are familiar with. So we use a discrete set of tools for most of our development. VIPM should be preaching to the converted here. We're big fans of that. We use that to manage all of our reuse libraries. The fact that you can build and distribute packages is obviously quite good. One of the great things about VIPM has always been the fact you can run it off the pallet. So you build a package, set it up right, and it's there. Everyone can use it. You just right click and it's there. It even links up with QuickDrop, which is awesome. You can provide it to your customers as a discrete package, which means you're not giving away everything, you're just giving them what they need. So yeah, I'm a big fan of VIPM, and we build that into a lot of our processes. OpenG as well, again, most of you should be familiar with that. If you are new to LabVIEW and you're not using OpenG, then get into it. Whenever you have a problem where you think, oh, there should be a VI that does that, and there's not a native LabVIEW VI, 9 times out of 10, someone else has thought about that in the past. They've created an OpenG VI, it's documented, it's supported, it's robust, it's going to work. So use it and use it as much as you can, because it's a good tool. Apart from that, we generally tend to avoid third-party tools, and the reason for that is we have systems which we're supporting. I mean, I'm supporting a system that's sort of 10 to 15 years old. They had some really cool ActiveX plugins that were awesome, but they're no longer supported. They don't work with Windows 10, so you've got to go in there and replace that with something that will work. So as a general rule, we try and avoid using those third-party tools on systems that we know going to have a long lifetime for support. And then, of course, like all good software developers, you use your general software tools. We use Bitbucket and Atlassian and stuff. Whether using GitHub or Trello or whatever, it doesn't matter. It's important that you have within your team that infrastructure to ensure that code's checked in, it's able to be shared, you're able to see what other people have done. We use Confluence for our release procedures, so all of our releases, we have that information in Confluence, and that links nicely with Jira and Bitbucket, etc. You know, choose your own tool, doesn't really matter, but it's important you have something in place for that. It's important that you have, or in our case, we have a lot of common code. We've built it up over a long period of time. We use log files in all of our applications. So when we have our application templates, we include all these things in there. So, and you'll see it, I'll do a bit of a demo later. You'll see all these things come essentially for free. We use HTML log files. I know other people use log files in different ways. Our HTML log files are pretty cool. It's nice. You open up the log file, it sits in the background. You can run your application, you can refresh your log file, and it just does its business in the background, which is awesome. Being HTML, you can use colors, you can embed images, links, whatever. It's pretty cool. Custom error codes, we have the same error codes across all of our applications, which means that if some random person rings up and says, oh, I've got a 5521 error, is most of the people actually know what that is and be able to point them in the right direction or work out what's going on. Even simple things like just having dialogues that look consistent across all the applications. We make sure they use the Windows buttons, okay, cancel, abort, retry, ignore, yes, no. Everyone who's used Windows is familiar what they all mean. We've all been in situations where a dialogue comes up and you're studying it going, do I need to press yes or no? And 9 times out of 10, you get it wrong the first time. So if you're using them properly, you don't have that problem. We have obviously reuse code for vision and database. But the key thing is, and what I probably will be covering here, is around our application templates. So we have one which we call the dynamic menu template, which is what we use for most of our applications. We have a template for our vision applications, which has a lot of the vision reuse code. We have a template for our touchscreen applications, so designed with big buttons and fat finger compliant, brings up on-screen keypads and the like. And then we have a very much a standard desktop template for really simple applications like a logging application or data acquisition. So I am going to show you a little bit of code here. Hopefully I'll get this to work. We have this template called our dynamic menus template. As I said, we use this for over half our applications. We also call it the Gmail template, and you'll see why in a second. We have already in that template, it has the project, it has a build, it has some dynamic VIs in there that are included in that build. If you want to talk to me about dynamic VIs, that's another discussion for another day. Don't get me worked up after a beer talking about dynamic VIs. They are a hassle, but if you have them set up right, then they're fantastic. The top level application is producer consumer. It's pretty basic, has all of our reuse code included. I'll just open it up if I can. Let's see if this works. Need my glasses. I'll see I'm way ahead of schedule, so we should be able to have a bit of a demo at the end. So here's the project. So this is just a template. Obviously, it's got our colors. The first thing we do is put a splash of paint on it, make it look like the customer's colors, get that immediate buy-in. You'll see it's got buttons on the left here. It's actually a sub panel here in the middle. and I can run this now. It's just got some basic code in the background. But the intention is that you would take this for your application and you would run with it. Now, the reason we call it the Gmail template is because all these buttons here act like Gmail buttons, where the buttons expand based on what you select. And what's happening underneath is each one of these top level buttons is actually its own VI. And underneath that, the sub buttons or the sub menus actually just trigger a main tab. So what that means, and we've had some situations where we've had some complex applications where there's like 30 or 40 different screens, and we've all been there. You see these screens with buttons everywhere, and sometimes you click on the left open, sometimes you click on the right. It's just a mess. We found this is a really neat way of really having those menus on the left, being able to expand and contract on the different screens that are available, and keeping a really nice, clean interface. The other advantage with using, I'll get to that in a second. So there's a bit of code built in here, so we can generate some errors. They're all handled. All these dialogues, the colours can be changed in one place, so you're actually using the same dialogues for all your applications. It's just different colours. Got some on-screen pop-ups and the like. So the idea is we give all this stuff to our users. Some nice stuff with the mouse in, mouse out, and about, yeah. The log file sitting in the background, that's just churning away, generating that in HTML. So that's already there, ready for you straight away. Now, everyone's looking at that going, oh, yeah, it looks okay, but what does it look like under the hood? All right, let's have a look. Avert your eyes. No, it's not that bad. So yeah, it's really just a basic producer consumer. This is the top level VI. There's a bit of work done initially to set up these buttons, but they're just dynamic events. So once they're set up, you don't need to worry about them. There's a VI to set them all up, the top level ones and all the sub menu ones. Just a basic producer consumer at the end of the day. All of our reuse code, you should be able to see that, I'll move that. All of our reuse code should have VI descriptions. So someone coming in using this for the first time should be able to navigate their way around it pretty easily. That top level application doesn't do much more than what you have here. All of the work is really outsourced to those sub panels, which is why we find this so useful. When we have these complex applications, if you're doing some work with calibration or configuration, someone might be doing some scripting, someone might be doing some vision, is you can actually put a sub panel for each one of those because they're different parts of the application. You have 4 different developers working in parallel in a reasonably efficient way. Clearly, if you're doing it with one person, it's going to be more efficient, but as I said, we're looking for rapid development, not rush. So I can say to a team member, sort out the configuration. They can work on the configuration screen. I can work on vision or something else. Someone else can do diagnostics or IO, and away you go. If I just go to the... So this is just one of the sub panels. This is a template. It's got a bit of code on there. But again, it's very similar, very basic producer consumer. We can use this as a top level VI if we want, if we're doing some testing, but everything else is very similar to that top level VI. It's just a producer consumer. If you're familiar with producer consumer, I can give this to you tomorrow and you can start developing code for me. That's the type of attitude that we're trying to have, because there's nothing worse than having a complex application which one person knows back to front. They go on leave, get sick, change companies, and then the rest of you guys have to try and suck it up, and it can be a bit of a mess. There'll be questions at the end. Is there any questions now on just that? Because that's the last I'll show of the code. You can obviously come and talk to me afterwards. Yes, go.
Buttons down the side.
Yep.
Are they physical buttons that you move around?
Yeah, there's
So source and control references.
Yeah, so they're 15 unnamed buttons, and then the name changes as you go down, and we force some indentation with some spaces. And so then when you select one, it grabs that name and that fires off an event.
Cool.
And every 5 years or so, you add 3 more because you get a big project.
Something like that. Usually what happens is you have a smaller project and you've got to cull some of them. So yeah, the biggest thing is actually, there's a bit of work usually around managing what are those buttons going to do. But that's great, that's design. That's looking at UI early on and saying, all right, we're going to put this into the calibration VI or top level VI, going to put this into diagnostics or IO, toolpath, vision, whatever. Sorry, there's another question.
Yeah, so what's your preferred method to pass data between the subpanels? So like if you do configuration, you want you want to access that data from.
I'm really glad you asked that. I'm really glad that Nick went before me, because we do use functional globals, but we use them in that way that sort of Nick suggested. We'll often have references to front panel objects from different screens in order to be able to pass them between. So there's a little bit of overhead in setting that up, but once that's set up, and that's usually the job of the architect at the start of the project, once that's set up, you can change something on one screen and see it on the other. And I'll show a bit of a demo of a working application. You'll see some of how that works. So there is a little bit of work getting that interfacing right, but like all things, once you've got it working, it's quite powerful. Yes?
Can the screen be maximised? And another question is, what screen size do you design for?
Yeah, look, so if you take the top level VI, you can change that size if you want. The only thing you obviously need to do is make sure all your sub panels are of the same size. And so usually that's one of the first things you're doing. One of the applications I'll show, there's actually another header in there, so the sub panels are a bit smaller. But yeah, you can make that larger without any problem. You've just got to, because of the way this is set up with frames, you usually have to play around a bit to get that size right. Can it be maximised? It can, but I would then need to change my sub panel size and a few other things. Generally, when we have this running in the field, it's only on one size, and it's generally a full screen application.
So can I ask what screen resolution you generally design for?
Oh, is it 19? I can't remember off the top of my head. Is it 1920 by 1012? But just the standard size. Usually, one of the first things we do with a project is find out. So, a production station, for example, is they'll say, "Oh, we want to put it on the screen. All right, what's your screen size? Oh, I don't know." Okay, well, you pick one, you work it out, and then you build your application. Because most of these, if they're production stations, they don't want to have access to windows behind. You just want to have your application hogging up all the space, being the only thing the operator can interact with. So that's very much part of the design process. Right. All good? Yes. Sorry, I didn't see you.
Have you used your user interface to integrate in text?
No. Where's Pete? No. There's been discussions about doing it, but we haven't done it yet. It's on the roadmap. As I said, this isn't a discussion about applications as such. This is the architecture that we've used. If you've got a group of people working with you and you're all signed up, drinking the DQMH Kool-Aid, fantastic. Build your infrastructure around that. Make sure your whole team is familiar with it, and make sure you're all rowing in the same direction. That's just the way we do it. Everyone's entitled to their own choice. Sometimes it is horses for courses. I mean, that application is suited for most of what we do, but may not be suited for everything.
I've got another question about your preferred architecture. There's something there that's missing in my mind that I recently came across a problem at work where I had to solve this problem. But what's your preferred method for running parallel asynchronous code or modules that can communicate back with your main producer consumer? Because that's a very real need, and that architecture misses that. But I can't think of that.
So essentially, why we see that as just an extra consumer loop for a particular purpose. So for our log files, for example, which uses dynamic VIs, that spins off a daemon that sits in the background. It's queues to and from in order to send information down. We use the same thing for our vision libraries, where we spin off we basically open a vision module that sits in the background that's running in its own loop, and that can be launched as the application initializes from the main VI. So that's generally the way we do that, and we just use queues to communicate between the different daemons that we spin off. Does that answer your question? Kind of, maybe?
How well does it integrate to the model that you have there?
It integrates quite well because the application here, all it's doing, the top level is doing, is essentially loading all these sub panels which are running in parallel, and they've obviously got a UI component to it. But you could have it so that when the application starts up, and usually there's a splash screen which does a lot of this initialization. When it starts up, it spins off your in my case, a vision module or a log module or something else, some other device which you want to talk to asynchronously. And that can sit there in the background. It's got its own while loop running. You want to make sure that, in our case, what we use a functional global called application stop, which means that when I exit my application, is all of those different modules are going to shut down at the same time. Otherwise, you get that awkward situation, we've all seen it, where you think you're closed, but there's 3 or 4 things running in the background that are still pestering away, clogging up memory. I can talk to you a bit more about it later if you like. I can show you some examples and some of the applications we've worked on. Right, good. So why subpanels? As I said, the reason we like it and the reason why I try and promote it within our team is that it allows us to split up tasks. All of our code is derived from a template that we're all familiar with. It does mean that our style will be similar, and I'll talk about style a little bit later. It allows that independent development, which is good for that rapid development for applications. Obviously, some people have specialities in vision, others might have speciality in wanting to interact with hardware, and you can let them do their thing and as a team get a good result. One of the real benefits in subpanels, which a lot of people don't know, is you can actually, when you're integrating in the developer environment, you can have your top level application running. You can actually select a subpanel. You can actually open up the one that isn't in focus at the moment. You can do some debugging on that, change your colors, fix a bit of code, close that, physically close it so not open, and then you can call it again from your main application, and you're effectively debugging while it's running. Not many architectures allow that. That's something that's actually quite powerful if you can get your head around it and you're set up in the right way. Why do we use producer consumer? As I said, you can teach anyone how to use producer consumer pretty quickly. It's a very standardized way of developing LabVIEW. If we have a new person join our team or we're doing some collaboration with people from another company, which often happens, we're using producer consumer. Oh, okay, great, no worries. You don't have to explain too much. It's all there and it's pretty easy to use. Why do we use VIPM packages? Like everyone, it ensures that we're using the same code throughout our application and our applications. And that's very useful. It promotes a lot of trust in the reuse code, because if it's coming off a package and we're using it elsewhere, then we know it should work as advertised. And that gives us a lot of confidence and increases that rapid development. So what else? What else do we do? What else do we do to make sure that as a team we're able to produce good code for complex applications? We want to encourage documentation. So you saw, we should have seen, hopefully, all of the sub-VIs in our reuse packages, all our reuse code should have VI descriptions, because you want to be able to look at it and see what it is without opening it up. And if you've got that trust and you trust that documentation as well, then you treat it like a LabVIEW VI or an OpenGV VI. You just know it's going to work as advertised. We encourage documentation of block diagrams. Case statements or while loops are something that we generally try and make sure we document. We've all been in situations where someone has some complex Boolean logic, like, oh, if I equals 0 and the enum equals initialize and this flag is, well, you know the ones, we've all seen it. Put it in your case statement, put it on the top. So someone reads and says, if I'm initializing and it hasn't been reset or something like that, then you know what that code does. You don't have to try and work out what's happening without actually going back and tracing it all. We encourage documentation through our Git commits. So as long as you've got processes and procedures that use these common tools, then it forces you to have some form of documentation. We force our documentation in our release notes. So that's one of the reasons why we use Confluence for that, because you can say, this is the version I created, this is the Jira issues associated with it, this is what it does. Link to the commit. Everyone's happy when you're trying to debug something that was released on an application several months ago. One thing we try and do, and I think this is really important, is getting everyone involved in the integration and testing of that top level application. Everyone knows that guy. I'm talking about the guy who writes that code, it works, checks it in, you're there testing it, all of a sudden you've got broken code, things aren't working. If that guy spends 10 minutes dealing with those type of issues, he's not that guy anymore. He understands, hopefully, after a period of time, you need to make sure when you commit your code that it's going to work, that other people are going to be able to use it, and it's going to do as advertised. So if you've got everyone involved in integration and testing at different times, everyone soon works out who that guy is, and they don't want to be that guy. I've been that guy before, don't worry, we've all been there. One thing that we also try and do is we really want to try and split up our application development from our package development. And this is, I think, really important if you want to maintain a really strong set of reuse libraries. We've all been in situations where we have an application, we've got a deadline, we're trying to get something fixed. We look at the reuse code and go, oh, yeah, I just need to make a slight tweak to handle this special case. It'll all be fine. The person who should make that change is not the person who's there going, oh, I've got to get this out tomorrow. You need the person making those changes to your reuse code to be someone who can take a step back and go, yeah, but if you do that, it's going to screw up all these other applications. So we try and ensure that the people doing the application development are segregated from people doing the package development. Now, there will be times when they have to do that, and that's when we, you have to be careful. But if you can make sure that maintenance of your reuse library is treated with far more care and respect than trying to get that build done by 5 o'clock on Friday and it's 4:30 and you're feeling thirsty. So try and keep those application and package development separate as much as possible. And get the basics right. I talked about that guy who always checks in code and it's broken. Issues where, developers are linking paths in the wrong directories, or don't update their reuse code, so they're using old versions. I would rather work with a developer who gets all the basics right and still learning about their LabVIEW, and their skills probably aren't quite as strong as that architect who's really fantastic, but he's always checking in code that's broken, or he's always the one that doesn't test stuff before it gets committed. It's really important, get the basics right. You can't work as a team if you don't trust each other. The final thing for here is we talk about having common development styles, talk about having style guides and using the same templates and all that, but we're not robots. The way that I might solve a problem is going to be different from the way someone else might solve a problem. So we've got to allow people to have creativity. If someone thinks it's a really cool way to solve it, let them do it. Make sure that it's documented, make sure they're not doing something completely stupid, like using dynamic VIs when they don't need to, but give them the creativity to solve the problem their own way. That gives them the buy-in, make sure they enjoy working on that project and working within the team. Here's just some examples using that architecture. So you see different splash of paint, different colours. We do a lot of different things with it. Got heaps of time. I could talk about this for ages. I will try and bring it down. So this is an example project that we worked on a couple of years ago. It was for one of our customers who we've had a long-term relationship with. We see them more as a partner than a customer. They have a technology for dispensing plasma, and they're having some rapid growth, and they wanted to build these production systems, which they're going to on sell to some of their customers who are based in North America and Europe and Asia. The hardware for this was coming from a company in China who built this all-in-one production system with motion and vision, has a laser for measuring height, it has conveyors and drawers and safety and everything you need. It meets semi S2 standards, so it's a very solid product. They had some software for it, which was workable, but fundamentally in Chinese, which wasn't really going to cut it in the US market, unfortunately. So they got us involved to do some development for them. Really strong interaction with hardware. A lot of these machines are going to be very similar, so very similar configuration for the ones around the world, but some customizations were going to be needed. You might be on one site where they want to integrate with an MES, might be on another site where they want to do some heating or a vacuum or something else. So we had to build from a common base, but be able to split it out in different ways. Incorporates motion and vision, and in this case, a very mature process. Our customers were needed to be able to provide that first level support, and their customers were looking to buy these for production systems to last for more than a decade. I've seen their projections. They're saying we want, this many machines till 2035, which makes you think a bit when you start developing your code. So that's a picture of what it would look like. Because I've got time, this is awesome. I'll just open this up. Someone kick me off if this is boring. I don't find it boring, I find it awesome. So this is the application. I'm just going to have it running in the background. Obviously, I couldn't wheel one in today, unfortunately. The sub panels, I've got a pointer here. The sub panels, that top header area is not part of the sub panel. So from operation down is a sub panel. For this particular application, because it's going to a number of high value customers, they got us to do some work with an industrial designer to get all the buttons sorted out. So that's why it looks a bit more fancy than most of our applications. Yeah, so what's going on? You see on the top left, so we have all the buttons on the left. That's just moving it around. So this is actually running it. So it's going to find a fiducial. What it does is it uses the cameras to find a position on in this case, a PCB. It adjusts the X and Y system and then runs what they call a toolpath, which is basically a script, a motion script to cover a particular region. So that's it running in practice. On this screen, so we have all the plasma stuff for it. So these are all code that we had already developed, and we can just drop that in, plug it into our architecture, and it works pretty much off the bat. You can see we've got ability to change roles. So that dialogue you saw before, so that comes with all of our applications, because I think most of our applications, and it's probably the same for most people, generally you have like an operator and a supervisor and an engineer, and they all get exposed, and different buttons on the left get exposed as a result of that. In this case, we have what we call a toolpath screen, which is just a like a development environment for an engineer to modify scripts. But this development, again, separate that off, segregate it from all the other development. It's quite a bit of work to get that done. We have in the past used some third-party tools and got burnt because they're no longer supported. So we do most of this ourselves, so you can actually generate it from the application, or as you'll probably see in a second, what you can do is you can actually spin it up into Notepad++. There's some functionality around that. This will run for another minute, and then we'll get to some more questions. But you get the idea. It's a pretty complex application. We had 4 developers working on this. We had one guy who joined us. He'd only been working for a couple of weeks, and he did a lot of the key work on this. We got him involved because he was the only one who could speak Chinese. So he did all the I/O, which was a bit of a struggle for the rest of us. But we were able to separate that off for him, taught him how to use produce consumer, and away he went. That's pretty much it from me. Let's stop that. You probably don't need to see too much more about that. Oh, I'll bring up log files in a second. That'll get me excited. Yeah, has anyone got any questions about this presentation? I'm sorry, we're half an hour early. I thought I'd go the full. Excellent. Okay. All right. Yes, John.
Got a philosophical question. How do you convince a small LabVIEW shop, maybe 1 person, 2 person team, to invest in the infrastructure of a good design pattern, if you will? Because I've seen cases where, because of business reasons, everybody wants to get the project done as fast as possible. I'm a big advocate of having proper processes, but it comes down to a business decision where they say, no, I don't have the time for that. But then you can see them getting into a vicious cycle of, running out of time for the application, deploying it, having the same problems come up again and again, and then having history repeat itself for the next one.
Yeah, I think that's a common challenge that anyone who's running an old school alliance company has come across. Often it just comes down to having those conversations with your customer and saying, are you building this application for now? In which case, hack away, get it done quickly, keep them happy. But if you're talking to a customer who's serious about their business and is looking to support something for a large period of time, and you say to them, how are you going to support this in 5 years' time when I'm not here? How are you going to support it in 10 years' time when you've handed over your business to someone else? If you have ask those type of questions and discuss those things with them, then maybe that promotes discussions about, okay, let's do a little bit more investment so that we're not spending 6 months every year trying to support this and spending 6 hours every year instead. That's the theory. I don't know how everyone else has gone with that. That's probably a good discussion for later. But that's certainly been my experience. If you have those conversations with them and they understand it, at least then they can make informed decisions.
I feel the best lesson is usually when they get burned.
They learn the hard way, yeah. And sometimes a little "I told you so" subtly done at the end of that will mean that the next project goes a bit smoother. Any other? Yes.
I've got a comment. First of all, great presentation, Liam. You mentioned DQMH earlier. We use DQMH at Whiting, and what you showed us, the template, it's so similar to what we've been doing at Whiting software, except you're using producer consumers and we're using DQMH. And in fact, DQMH could integrate into what you're doing.
Yeah.
Because all it is, a DQMH module is essentially what you're doing, but it's just got a bit of automation around. But yeah, it could actually integrate really well.
Yeah, I know enough about DQMH to know that I probably should look at it a bit more, because it's I think Fabiola probably had, well, obviously she's a very talented engineer. She thought about this long before I did, and came up with that, and that's certainly worked well for her and all the people using it.
But it's great to see how you're going about it, and it's very similar to what we're doing as well, which is really interesting.
Good.
Yeah.
Good. Yes.
What's your opinion on preference on control palettes? I'm talking about system controllers or other palettes, and fonts as well.
Okay, I'll start with fonts. So for our professional applications like that, our industrial designer gave us a really nice font, which we use and we distribute it with our executables. A little bit of overhead to do that. It does make a difference having a font which has like a normal, a semi-bold and a bold. You know, it's a bit better than just using Arial or Courier or whatever. I don't think anyone uses Courier. System controls. So yeah, we have a mixture of sort of the front panel controls. So I told you about those buttons where we got an industrial designer to help us out with those. So we created a button set for that. We don't do that for all of our applications because it's just a lot of overhead. You have an application, you create a button set, and then someone says, oh, we need a print button. It's like, oh God, how do I design a print button that looks consistent with all the other colors and all that? So we generally try and keep things simple in that regards. We'll usually create, like in this case, all our rings look the same. So we create a set of those if they're rings, and differentiate them from the enums versus the rings, have them set up in a similar way. So yeah, we do create a lot of front panel controls, which we actually create packages around, so that if that control changes, then someone else, if they update the package, are going to get that updated version. Does that answer your question?
Controls in the library,
Well, for this application, there's probably about 40 or 50 controls, mainly just the buttons. There's a whole bunch of type defs, which are just, LabVIEW type def clusters. There's quite a few of those that we use for passing data around. And again, you'll need them in different parts of the application, different subpanels. So probably hundreds at the end of the day.
Did you ever use any X controls?
We did look into them at a point in time, but never really got sold on it. There's a couple of times where you look at something and go, an X control might work here, but I haven't got the time or the energy to bash my head against the wall and get it right. Maybe other people have done that, and if so, they're probably better than I am. No surprise.
I added a comment to that. If you're looking into X controls and interested in their capability, there's another equivalent called Q controls, created by one of the LabVIEW champions, which has got a lot more dynamic capability about them. Worth checking out.
Yeah, they struggle with dynamics, and we're just progressively removing them from our
The X controls?
Yeah.
I think you're probably better off just using a subpanel nowadays and treat that as a control, because you really like them. They didn't exist, I think, when X controls originally came out.
Yeah, I haven't seen those Q controls. I'll have to have a look at that.
Anything on font size?
Yeah, it was usually that balance between making it nice and big and readable. I mean, if you're on a touchscreen application, which people are going to be looking at from a distance, then you need to have them nice and big. If you're going to be putting them on an application where they've got a keyboard and mouse like this one, and going to be close, you can make them a bit smaller. It's always that trade-off between how much real estate you have, how much clutter you want on your screen, and what looks nice. We'll standardise within an application. So for this particular application, is all our fonts are the same, all the labels and all the labels are the same size and the same font and the same colour. So when this is not typical of our applications, because this is one which we built to be, and our customers willing to pay for it to be a really top-notch, professional-looking application. We don't always get industrial designers in to help us, get those get those shades right and look at the color palette and give us that beautiful chart of use this for that and use this for that. But when you get the chance to do it, it's pretty cool to work with, to be honest.
That menu on the left, how does it expand out? Is that a cluster?
It's so each one of, so if you were to click on the diagnostics button, so they're all buttons. Each one of those is a button. As I said before, we have 15 buttons sort of stacked up on top of each other. As you select one, there's some code underneath that'll say, okay, this is diagnostics. There's a whole bunch of sub menus under that, and then it'll label and make visible the buttons underneath it and adjust them all accordingly. So that's why we call it the dynamic menus template, because as you select one of the menu options or those buttons, it just changes. Maybe they're not in a cluster; they're individual. We set them up as we add them all as a dynamic event structure, so that we can handle them all the same way. So as you select one, it'll say work out where it is, what it's called, and how the other ones adjust accordingly. I can show you afterwards if you like. We can run that. It's a little bit of work into our reuse code in order to get that to work, but once it works pretty well all the time, and it's quite a nice feature that we're pretty happy with, to be honest. Okay, well, good. Well, thank you very much for your attention. It's been a real honour to speak at GDevCon, and if you have any questions, we'll be outside. I look forward to talking to all of you at some point in the next couple of days.